You just subtract everything else from 360.
Right, so you just do 360 minus 82 minus 37 minus 109. And whatever that is. And that'll be the answer to part A. What about B? Now B is, it's no longer a quadrilateral. It's no longer a four-sided diagram. So what do the angles add up to in that case?
I forgot the formula to like figure that out.
How many sides does this have?
5.
That is a pentagon, right?
Mm-hmm.
The angles inside of any gon adds up to n minus 2 times 180. Where n is the number of sides.
So 355.
All right. Wait. What'd you do? You subtracted all of them from 540? Is that what it is?
Mm-hmm.
Yeah, that's
Wait.
good.
Yeah. Mm-hmm.
It's good. Bob claims the sum of the interior angles of a regular octagon is 900. Is that true or false? Octagon, that means it's an 8-sided diagram.
Wait, so it's just 8 minus 2 times 180?
That's right. What is that? 6 times 180. So is he right or wrong?
Wrong.
Yep. It should have been 1080, not 900, right?
Mm-hmm.
6 times 1080. Or sorry, 180, which is 1080. Calculate the measure of each individual interior angle of a 25 gon. So 25 gon, that means n, which represents the number of sides, that is 25. And we want to find the individual angle. I mean, it's very hard to draw 25 gon, but like we need to find the measure of each individual angle. What do we do in this case?
You would like use the formula and then divide it by 25.
Right. So n minus 2, so 25 minus 2 times the 180 gives us the total angle. We're going to divide the total angle by 25 to get the individual angle. 23 times 180 divided by 25, and that gives us 165.6 degrees. What is the measure of each exterior angle? Now we're looking for the angle here, the individual angle down there.
Isn't it supposed to be like 360 or something?
Yeah, so the sum is 360. The sum is 360. And then we need to divide this by 25 because it wants the individual angle. So 360 divided by 25, and that is 14.4 degrees. Alrighty, in this one, we're trying to find angle X. To find angle X, we have to find this angle first. To find that angle, you have to find these two angles first. How do we do this?
You subtract each from 180.
Right. So 180 minus 85 is 95, and 180 minus this is 60. Now what?
Now you take those two and subtract them from 182.
Right, and what does that give?
25.
Yes. So if this is 25, what is x?
155.
Yes. Let's look at B. So they want to find this angle here, x. How do we do this? So you need the other two sides of a triangle, the angles, to find the third missing angle.
You subtract 162 from 180, which gives you 18.
Yes. And how do you find x from here?
You add those two other numbers and then subtract them from 180.
That's correct. So it's 180 minus 65 minus 18. So x in this case is 97. Let's look at C. So there's no x. Oh, there is an x, but they have not given us any numbers for this one. So let's first count how many sides this has. 3, 4, 5, 6. It has 7 sides. That's a heptagon.
So 7 minus 2 times 180.
Yes. So,
it's 900.
right, so this is the sum of all the angles. How do we find x from here?
You just divide it
By?
7.
Yes. Not by 7 minus 2, just by n, okay? By 7. So 900 divided by 7, and that is 128.57. What about D? Again, step 1, find the number of sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 9 gone.
You divide 360 by 9.
That's correct. 360 over 9, yeah. 360 divided by 9, and that gives 40. And you are done. Calculate the value of x in each case. Let's look at the first one. How do we go about doing this? It's going to turn into a linear equation.
You subtract 145 from 180.
Right, that is 35. And then? What do the angles in a triangle always add up to?
180.
180. That means if you're to add all three of these, x plus x minus 25 plus 35, this is going to add up to 180. Right? And here we're going to take like terms. X plus x is 2x, and minus 25 plus 35 is plus 10 equals 180. There you go. You have a linear equation. How do we solve this for x?
You subtract 10.
Right. So that's 2x equals 170, and then?
You divide by 2.
Right, that gives you 85 degrees. So x is 85 for A. What about B? Now that's again a four-sided diagram. It's a quadrilateral. That means it's going to add up to 360, right? The angles in this diagram, if you're to add all of them up, you get 360. So we're just going to set the equation. Now what do we do in order to solve for x?
You take the like terms, like all the x's.
Yes, so x plus x plus x plus 2x is 5x, and minus 35 minus 75. So here's how you do this in your head. 70 plus 30 is 100, and then you have 5 and 5, so this is minus 110.
Okay.
So you got 5x equals 470. Divide that by 5. It's going to be 90, and 20 over 5 is 92. Actually, it's going to be 94. 470 over 5, right? So 5 does not go into 4. 5 goes into 47 9 times 20, and then 5 goes into 24 times 20, 0. X is 94 for part B. Did that make sense?
Yeah.
Alrighty, now we're gonna do something different. At the same time, it's pretty similar, but let me see where the cheat sheet is in case we need it. It was somewhere here, the diagram that we're looking at last time, the last thing that we looked. We don't really need it, but it would be nice to have this thing right here. So let me just draw you a sketch. So let's say you have a point 0, 0. You have a line segment that's going to go through 0, 0, and that goes through 5, 3. Something like this. It's going to go on forever, but we're just interested in this little tidbit. So on the x-axis, it's 5. On the y-axis, it's 3. Now the question is, how long is this line segment? What does your intuition tell you?
Is it just 5?
No, it's not just 5. It's going to be longer than 5. If you look at it, it's a right-angled triangle. In any right-angled triangle, by right-angled triangle, I mean this sign right here. That means these two lengths are perpendicular. You have AR BAC. And we know from Pythagoras' theorem, a squared plus b squared is equals to c squared. In this case, we're looking for c. We're given what a is. A is the height of the triangle. So in this case, a is 3. So 3 squared plus b squared is the length of the base. So that's 5 squared equals c squared, like that. So 3 squared is 9, 5 squared is 25. This is going to be 34. If c squared is 34, what is c?
It's 17.
What's 17? No, let's not. Try again. Again, this is also linear equations. C squared is 34, not 2c.
Oh. So the square root?
Right. So what's the square root of 34?
I'm not sure.
So the square root of 34 is like 5 point something, right? You just plug it in the calculator.
Oh, okay.
It's close to 6, but not quite. What is it exactly? It is 5.83. So the length of this line segment is 5.83. Okay.
Okay.
Now, why is this important? What if I were to do this? Something like this, and boom. Now I've turned it into a quadrilateral. And what I'm going to do is I'm going to give you these 2 points as well, okay? So that's 2 minus 2 minus 2, 2 on the x, minus 2 on the y, hypothetical points. And this one is 7 minus 1. Now we know this line segment is 5.83. The
Mhm.
question is this four-sided diagram a square?
Yeah.
No. It looks like a square, but because I'm trying to trick you. We need to find out the value of this line segment. You see this line segment?
Mhm.
Now, what's the property of a square? A square means it's more difficult actually than you think. All four sides have to be equal, right?
Mhm.
So step one, let's check for the lengths. So if this is not 5.83, then this is not a square, because that's the very first rule. All four sides must be the same. So we are going to find the length of this line. Okay. So to do that,
Mhm.
we're just going to turn it into another triangle like that. And now we're trying to find the length of this line segment. From 2 to 7, what's the run?
5.
From -2 to -1, what's the height? Or the rise?
1.
1, right? So again, Pythagoras theorem, BAC. A squared plus B squared equals C squared. A is 1, so 1 squared plus B is 5. 5 squared equals C squared. You see that?
Mhm.
A and B doesn't really matter. Like you can say this is A or this is B, like you can switch them around, but C
Uh-huh.
absolutely has to be the hypotenuse of the triangle. That means it's the opposite side from where the right angle is.
Okay.
A and B, you can switch it around, not C though. So you have 1 squared plus 5 squared equals C squared. And that means it's 26 equals C squared. See, last time we had 34. And if you're to square root both
Mhm.
sides, the square root of 26 is not going to be 5.83. It is 5.099.
Uh-huh.
So is this actually a square?
No.
Right? It's not, right? Yeah, that's the first check. Check for the lengths of the line segments to see if they match up. If they don't, then it is most definitely not a square. The same question I can ask you something else. Is it a rectangle?
It's not.
It is not, right? Because even on a rectangle, the side lengths have to be the same. The opposite side lengths
Mhm.
have to be the same. So this is neither a square nor a rectangle. And eventually they're going to ask you which one of these it is. So I'm just going to have this open on the side so we can refer back to it after doing some calculations. Where did I want to go? I wanted to go to the shapes part. And where is that? Not a whole lot of questions here, is there? That's good for you, I guess. I'm sure it's at the end of the chapter. So that's that's the main part of this unit, is to determine whether something is this or that. Let me see. They've given us any questions. That's annoying, because there's not a lot of questions here, but that is fine. I'm gonna make up some questions. Now this is where it gets as difficult as it's gonna get. I'm gonna give you some points. Okay, so A is 4, 4. B is 2, 2. C is -2, -3. And D is, so 4, 4, 2, 2, -2, -3. +3, positive, or -1. There you go. +3, -1. Now, again, there are 4 points, right? 4 points. Each of them, they represent a vertice, like this pointy thingy. See that?
Mhm.
It's called a vertex. So each point represents one of them. And the question is, what kind of a diagram is this? That's the main idea. What kind of a diagram is this? I mean, we can eyeball it, right? but we have to prove it. That's the whole point. We could eyeball it, so I'm just gonna draw it out. So 4, 4 is right there. You see, that is A, 4, 4.
Mhm.
B is 2, 2, 2, 2 is right there. B, 2, 2. And then we have C is -2, -3. 1, 2, 3. C is -2 is here, and -3 is down there. And D is +3. Let me just make this +3, -3. So 1, 2, 3, right there, and right there. You see that?
Mhm.
I'm gonna connect all the dots to join the diagram. Like that. The question is, what kind of diagram is this? I
Like
mean,
triangle.
a triangle is most definitely not a triangle because a triangle only has 3 vertices. The fact that this has
Oh.
4, right? 4 different points, it is not a
Mhm.
triangle. So how do we prove that? Step 1, what we're gonna do, okay, what we are gonna do is to find the lengths, okay?
Mhm.
So I'm gonna do this to this, B22 to A44. So we're just gonna do the Pythagoras theorem, but there's an easier version of Pythagoras theorem, which is called the distance formula. It is literally the Pythagoras theorem. And now what does that say? The distance between 2 points on a line segment, that is equals to y2 minus y1 squared plus x2 minus x1 squared. And that comes from the Pythagoras theorem. So this is a shortcut way of finding the distance. So let's first find the distance between AB, okay? The distance between AB. We could always draw a triangle, but this one is a little bit easier. It's gonna save us some time. Y2, so you can pick any of them as x1, y1, and y2, x2, y2. So I'm gonna pick A as my y2 and x2. So 4. Y2 minus y1 squared, so 4 minus 2 squared, plus x2 minus x1, which is also going to be 4 minus 2 squared in this case. Do you see that?
Mhm.
This is x2, y2, and this is x1, y1. So we have 2 squared plus 2 squared. We have square root of 8, right?
Mhm.
And what is that? That's going to be almost 3, but not quite. That is 2.83.
Okay.
And we're going to do the same thing for the side that's down here. Obviously, we know this is not a rectangle, right? But we have to prove it that it's not. And what's the easiest way of proving it is finding the distance between 2 points. Let's look at down here. We're going to use the same formula, distance between C and D. Distance CD is equals to, what do I plug it in here? The formula is the exact same. So what are the numbers that we plug in here?
-3 and -3.
So -3 minus -3, yeah, squared. What
Mhm.
about the other one?
-2 -3.
Right, -2 minus 3. And then you have 0 squared plus 5, -5 squared, which is 25. And square root of 25 is a 5. So that means this line segment here is 5 units. Okay, maybe I should use a
Mhm.
different color. This is 5 units here, and this is 2.83 units. Now, what does this allow us to do? Is this a square?
No.
No. Is this a rectangle?
Nope.
Is it a parallelogram?
No.
No, it is not. So that kind of just leaves us with is it a rhombus? Now, what the hell is a rhombus? Rhombus is the same thing as square, but it's slanted. All 4 sides are equal, okay?
Mhm.
But instead of it being 90 degrees, it's gonna be non-90 degrees. So now is this a rhombus?
No.
No, it's not, because all four sides of a rhombus are equal.
Mm-hmm.
If all four sides of a square are equal, but for a rectangle and parallelogram, the other sides must be equal, right? Not all four sides, but the opposite sides must be equal, like here. It kind of just leaves us with one option, which is it a trapezoid? And yes, it is. A trapezoid is that thingy that has no equal sides. Yes. And now, what kind of a trapezoid is it? What kind? So you have a irregular trapezoid, yeah? Or
Mm-hmm.
you can have something called a isosceles trapezoid. In an isosceles trapezoid, two sides are equal, not top and bottom, but left and right.
Mm-hmm.
So any ideas on how we can deduce whether this is a irregular trapezoid or an isosceles trapezoid?
It's an irregular one
Yeah, how do you know?
because the sides aren't equal.
Yes, that is it. It is an irregular trapezoid. Right? You see how that makes sense?
Mm-hmm.
Very surprised they don't have many questions on this topic. Maybe they're just trying to introduce us to it, which is okay as well. I mean, let's see. I'm gonna draw a circle, not gonna do that. It's okay, we can move on to the other part of shapes, which is called measurements. Let's see. And everything that we do here, it's gonna be very relevant to grade 8, but it's gonna be like dialed to 11. So if you can do the things here, things in class is gonna be way easier. That's the main goal, okay?
Mm-hmm.
So we've already done the equations, like we could keep doing it, but that's not gonna help you too much because there's something called diminishing returns, right? And how does that work? So you put the time here on the x-axis and you can put your score on the y-axis. And the law of diminishing returns, it tells us something like this. How would you describe this curve? What's the trend on this curve? This would be a communication problem in your data unit.
Mm-hmm.
Any ideas?
Not really.
Not really. Okay, that's perfect. That's okay. That's what I wanted you to say as well. But if you look at this, as time goes up, what happens to the score? Does it go up or down?
Up.
Yeah, exactly. So the more you study, the higher you score, right?
Mm-hmm.
Part A. But then if you were to look at something called a tangent. Tangent means the slope, okay? It's just a fancy
Mm-hmm.
word. What is happening to the slope as time goes up? What is happening to the slope of the graph? We started off almost vertical. And it's becoming
horizontal.
It's becoming horizontal. So is it going up or down?
Down.
Down, exactly. It's going down. So what does that mean? And that means this thing, right? This pattern, it's increasing at a decreasing rate or increasing rate?
Increasing.
No, decreasing because the slope is going down.
Oh, okay.
So the more you study, the higher you score, but the time you put in is eventually gonna concave out. Like you're not gonna make as much of a progress after 10 hours or after 5 hours as you did in the first hour.
Mm-hmm.
So this is the law of diminishing return, okay? And this applies to a lot of things in life. That doesn't mean you shouldn't study, but after a while, if you're studying the same thing, you won't learn much. That's the point I was trying to make. Anyways, the question here is to find the area of this thingamajig basketball court. All right, what do they want? Let me recheck this. Area and perimeter. Area and perimeter. Let's do the easier. Let's get the easy thing out of the way. I don't know if it's easy, but let's get the perimeter out of the way, because that is usually easier than finding the area. But now you're gonna have to be careful, okay? What does perimeter actually mean? It means
The outside.
the outside, right? So the perimeter here would be this plus this plus this plus this, like all the outside part, not the inside parts. Don't add these up. See the dotted lines? Don't add those up. It's just strictly on the outside. So in this case, what do we add up?
Oh, you could add 10 squared.
10 squared?
Well, that's for one shape.
It's not squared. So for the first shape, again, perimeter is the sum of all sides, right? So we have 10 here, this one, plus we have 18 on top. What's the length here?
10.
10, right? What about here? What is the length of this?
It's 18 minus 4.5.
Right, it's 18 minus 4. And a composition, this is called a composite diagram or a composite shape. That just means it's made up of something that's mixture of a bunch of different things. Doesn't have to be triangles all the time. That is 13.5. So plus 13.5, right? So that takes care of the unit on the top, and on the bottom we have 10 plus 18. If that's 10, then this should be 10 plus 10 plus, again, they're same triangles, sorry, rectangles. So this should also be 13.5, right? 10 plus 18 plus 10 plus 13.5 plus 10, just add all of them up. That gives us 103. What's the unit of perimeter?
Just meters.
Right, it's just meters. And you are done. Okay, what about the area? Now, area doesn't care about the dotted line. Because area is how many things can you fit in this thing. So again, the dotted line does not matter for area. So let's look at the rectangle on the top. What is the area of the rectangle on top?
18 times 10.
Yes, 18 times 10. What about the one on the bottom?
It's the same.
It is the same, plus 18 times 10. 180 plus 180, so that's 360. You add the two areas up. What is the unit of area?
Meters squared.
Yes, meters squared. And we are done. So they've given us 1, 2, 3, 4, 5, 6. So this is a sexagon called a hexagon. And the question is to find the area of a hexagon. How do we?
Is there a formula?
No, not for a hexagon, but we just have to use logic using the shapes that we already know. They've cut this graph in half, yeah? So what are these two shapes called? If you were just strictly look at this bottom half or the top half, what kind of shape is that?
I think it's a trapezoid.
Yeah, it is a trapezoid. In fact, it is an isosceles trapezoid because you see that these two, that means it's
Mm-hmm.
equal. This length is equals to this length. And the question is to find the area, okay? The area of a trapezoid. And there is a formula for this. The formula goes something like this. You're gonna need the height h, you're gonna need
Mm-hmm.
the top side a, and you're gonna need the bottom side b. And the formula is a plus b times the height over 2.
Mm-hmm.
And this is the area of a trapezoid. Doesn't matter if it's regular or irregular. Using this, what numbers do we plug into this?
2.5 plus 7.
No. So A and B represent the top side and the bottom side, okay? 2.5 is the height.
Mm-hmm. Oh, okay. So 3 plus 7.
Like that. 3 plus 7 is a 10. 10 times
Mm-hmm.
2.5 is 25 over 2. So the answer is 12.5 centimeters squared. And that's the final answer.
Uh-huh.
So this one, the question is find the perimeter as well as the area of this composite diagram. This is a little bit interesting. So 1 centimeter there means 1 centimeter up here, yeah?
Mm-hmm.
So on all these edges, you have 1 centimeter on each side. So what is the actual width of this diagram?
10.
10, right? And what's the actual height of this?
5.3.
Right, 5.3 centimeters. Now again, the perimeter is easy, right? You just add everything up. So perimeter is 8 there plus 1 here plus 1 here. And then you have 3.3. Then again, you have two different ones here, 1 plus 1. You just keep going like this. You keep adding up all the sides. So I started here. So right now I'm here, 1 plus 1. Or you can even do times 2, whatever you feel is easier. Plus 1, like that. Literally add all the sides up and whatever that is on a calculator.
Mm-hmm.
How do you find the area of this diagram? That's a little bit more complicated. So
Do
to
you have
do,
to like do
yeah,
something and then subtract?
yes, you do have to subtract. You have to find the total area of this diagram, okay?
Mm-hmm.
And you're gonna have to take out these 4 edges. So again, we know the 4 edges is a square, right? 1 and 1.
Mm-hmm.
So the area to subtract is 4 times 1 squared. And that
Uh-huh.
is just 4 centimeters squared. This is the gap, okay?
Mm-hmm.
Without the gap, what's the area? The total area of this diagram. Without the gap, it becomes a rectangle. By total, I mean like this thing right here. So if you were to just fill up the gaps, it's gonna become like a rectangle.
So 10 times 5.3.
Yeah, exactly. 10 times 5.3. And then you want to subtract the edges, right? 4.
Mm-hmm.
So 53 minus 4, it is 49 centimeters squared, and we're done.
Okay.
What kind of a shape is this?
Trapezoid?
Yes, it is. Is it an isosceles trapezoid?
Yes.
No. Oh, yes, actually, you're right. My bad. Yes, it is. And if you remember the formula for a trapezoid, right? The area of trapezoid is this is A, this is B, and this is H. It's A plus B times the height divided by 2.
Mm-hmm.
So we just plug everything. 8 plus 11.8 times the height, which is 9, over 2. And what does that give us? 8 plus 11.8 times 9 divided by 2. 89.1 meters squared. That's the final answer, and we are done.
Okay.
It's pretty simple once you know what formula to use.
Mm-hmm.
Have we done circles? I think we have, but I don't know if you remember.
I kind of remember.
Hmm. All right, this one's a little bit tricky. So they just want the area of the blue section. So that means we need to find the area of the total, the big circle, right? The giant circle on the
Mm-hmm.
outside. And then we subtract the 2 areas on the inside. How do we go about doing that? What's the formula for an area of a circle?
It has like something to do with pi.
It does.
Pi times r squared.
That's correct, yes. So we need the radius, okay? We know the radius of the small circles. The question is,
Mm-hmm.
what is the radius of the big circle?
Uh, is it like 6?
It is 6, so we gotta go this way, right? The radius of a circle is same in any direction. So that means going up is 3, going down
Mm-hmm.
is 3. 6 centimeters. That means the radius of the giant circle, the big circle, is also 6.
Mm-hmm.
So the area of the blue part is the total area of the big circle on the outside, right?
Mm-hmm.
Subtracted by 2 times the area of the small circles, because there's 2 of them.
Mm-hmm.
How do you find the area of the big circle?
Pi times 6 squared.
Yes, pi times 6 squared minus 2 times, what's the area of the small circles?
Um,
It's pi times 3 squared, and there's 2 of them. Right?
mm-hmm.
Now, why don't you plug this in a calculator and tell me what you get?
Okay. Wait, so pi times 3 squared?
The whole thing. So pi times 6 squared minus 2 times pi times 3 squared.
It's 56.55.
Right. Let's see if that's right. Yes, that's correct. Okay.
Mm-hmm.
So if you look at this diagram, It is a hexagon, 6 sides are equal. And what do we know? We just know the height on the inside and the side length on the outside. Question is, we're trying to find the length of the wooden frame and the area of the glass.
Um,
Any ideas?
um, Wait, so what exactly does he need?
So we're trying to find the length of the gray part that's on the outside
Oh,
and the area of the blue section on the inside.
do we cut it in half to find the area?
Yes, we do. So then we have two trapezoids, right?
Mm-hmm.
So if that's 1, this side also must be 1 meter. And this is A, and down here is B.
Mm-hmm.
We know the height, but do we know what A and B is?
Um, it is just 1.16.
That's right, 1.16. What about B?
I'm not sure about B.
The distance from the center to the middle of each side is 1.
Oh, so it's just 2?
Yeah.
Okay.
So for the perimeter of the wood, you just add all the sides up, right? It's
Mm-hmm.
1.16 times 6. It's multiplied by 6 or added 6 times. For the area of the blue thing of the glass, right, we're going to use A plus B times H divided by 2. Yeah,
Mm-hmm.
so it's going to give 1.16 times, or sorry, plus, if this is 1, then that means this is 1 and this is 1, plus 2, right?
Mm-hmm.
Times the height, which is 1, divided by 2. And whatever that gives on a calculator. And the area should be in meters squared, and the perimeter should be in meters in terms of units. Okay.
Okay.
Let's write in this fun diagram. It says find, perimeter is always easy, right? Perimeter is
Mm-hmm.
probably the easiest, but let's just focus on the area for this question. How do you go about finding the area?
Um, could you just like cut it in half to the part where it becomes like a triangle?
Which, from where? Like here?
Mm-hmm.
Okay, yeah, that's good.
Um, I'm not sure about the other side.
So let's first find the area of this triangle on the right. So area of the
Mm-hmm.
triangle on the right. The formula for area is base times height divided by 2.
Mm-hmm.
So what is the base of this triangle?
Is it 4.1?
It is 4.1. Now, what is the height of this triangle?
Um,
See, the whole thing is 6.2, right?
mm-hmm.
And up until here, it's 4.1.
So you subtract it?
Yeah, subtract it. Subtract 4.1 from 6.2. That'll give you 2.1. Base times height divided by 2. There you go. And that is going to give the area of the triangle that's on the right. 4.1 times 2.1 divided by 2. So that's 4.3 meters squared. So this part is done. Now let's look at the things on the inside. How do you find the area of this tail section?
Could you just turn it into a rectangle?
Yes, you turn it into a rectangle. And then we're going to subtract what?
The triangle?
Yeah. So what is the area of the rectangle? What times what?
The two sides?
So what's the length of this and what's the width of this?
4.1 times 4.1.
No, not 4.1. This 4.1 is good, but not that 4. See, that goes all the way till here.
Oh,
So that's going to give you an area that's bigger than that. We just want this part here, just this part.
so 2.1?
Yes, 2.1. And that takes care of the rectangle. But now we have the area of this thing.
Mm-hmm.
What do we subtract from it?
The triangle?
Yes. So for this triangle, what is the base?
It's 2.1.
Yes. Base times height, right? What's the height of that triangle? Again, height means this.
2.1 minus 4.1.
No. So height is the length from here to here, right? See, it's 1,
Oh, okay.
right? From here to here, from there to there, it's the same thing as from here to here. So
Mm-hmm.
that height is 1, and then we divide that by 2. That's going to give us the
Okay.
total area of the tail, right? Do you understand that? Rectangle minus the triangle there.
Mm-hmm.
So 4.1 times 2.1 minus 2.1 divided by 2, and the answer is 7.56 meters squared. And the total area is this plus that.
Uh-huh.
And we are done with this question. Okay, does that make sense to you?
Okay. Mm-hmm.
What about this? Calculate the area of the shaded part. So blue part.
How do you find the area of a triangle again?
Base times height over 2. So the area of the blue part is the area of the rectangle, yeah?
Mm-hmm.
Actually, we don't even need to subtract anything. The area of the blue part is pretty simple. So the height is 8 and the base is 18 for the triangle, right?
Mhm.
So area of the triangle is base times height over 2. The base is 18, the height is 8 divided by 2. That gives us 9 times 8, which is 72 centimeters squared, and you're done.
Okay.
Pretty simple, yeah?
Mhm.
This one was. Anyways, we should call it a day there for today, and I'll see you next
Alright.
time.
Thank you. Bye.
Bye-bye.